Hello, students. Welcome to another episode of FOMS Physics. This should be the video for day 12 and 13, which would be April 14th and 15th. Hopefully, you enjoyed Professor Thor's instruction. He's definitely different, but he said, I don't want to deal with the math stuff. So I came in, I'm like, okay, I'll do this. So let's go ahead and get started. Let's talk about putting together voltage, current, and resistance into something that means something. Uh, there's this thing called Ohm's law. Ohm's law says that the current, which is the rate of flow of charged particles through a circuit, uh, between 2 points is directly proportional to the voltage across those 2 points. And Ohm's law is over here. It's in this square. I is equal to V over R. That is Ohm's law. If the voltage increases, if you want to keep the current the same, if you increase the voltage, you have to increase the resistance. Or if you decrease the voltage, you have to decrease the resistance. So whatever happens over on one side, the current is always going to be proportional to that. If you increase something on the right side, V over R, then your current is going to increase. And that is Ohm's law. But you can see Ohm's law in a different way. Sometimes you see it as V equals I times R, which is just the same thing here. This little triangle helps you kind of figure out what to do to calculate a certain value. So V is equal to I times R. And that's this one right there. V is equal to that times that. If you want to find current, it's V over R. But if you want to find R, resistance is equal to your voltage divided by your current. And that's essentially Ohm's law. To make your life easier, maybe just remember it as V equals your current times your resistance, or you can actually go by Ohm's law, which is the current is equal to your voltage divided by the resistance. It's all the same. So what I want to do is I want to work some problems with you. You are going to have to work several problems using Ohm's law, and I currently cannot find my stinking pen, so I'm going to have to use my stinking finger to do this. So your problems will look very similar to this. They're not going to be very difficult. So let's take a 15 ohm resistor, and it's going to experience a current of 0.1 amperes. Well, what is the voltage of the battery in this circuit? So what I'm looking for is, oh, we got to pick a pen. Let's go blue. V is equal to I times R. I'm looking for the voltage of the battery, and I know the resistance, and I know the current. So I'm going to take 0.1 times 15, and that is going to equal, yes, 1.5 volts. My battery is at 1.5 volt battery. And there you go. That is Ohm's law. I'll work two more problems. And see, that should change that later. I have a 25 ohm resistor experiencing 0.36 amperes of current. What is the voltage of the battery? So V is equal to I times R. I'm going to take 25 times 0.36. Now, I don't have that number memorized, so let me go ahead and bring it over here. And let's see. I'm taking 25 times 0.5, is that 0.36, sorry, 0.36, and that is, oh, it's a 9-volt battery. So whatever that 9-volt battery is powering, well, it's 9 volts. So your answer, your voltage is 9 volts. All right, last problem. I have a 33, and that should be 33 resistant or 33 ohm lamp. It's connected to a 12-volt car battery. And I want to know what the current moving through the circuit is. Well, if V equals I over, or I times R, and you're trying to find the current, which is I, then you need to divide by the resistance. So I is going to be V divided by R, which is actually Ohm's law to begin with. So I take that voltage, which is 12, I'm going to divide that by the resistance, which is 33. Take my handy dandy calculator. I'm going to take 12, nope, figure all that out. 12 divided by 33. And the current is 0.36 amperes. 0.36 amperes. And there you go. That is how you work Ohm's law. Ohm's law is, it's not a difficult thing. And when we draw our circuits, we're going to include Ohm's law in our circuit. We're going to include the voltages and the current and the resistances, and you'll be able to calculate whatever it is you want. So that is it for today. You will have an assignment on this. I will talk to you later.